All right, sweet.
All right. Well, I didn't have nearly as much time to prepare for this talk. So I decided to add, in lieu of like, a bunch of slides with organized information, just a bunch of like live coding sections. So we'll see how this goes. But I do have, at the very least, a presentation. Although Zoom is suddenly giving me some very strange, we'll go with that, yeah. I actually might need to rejoin because I guess on this computer I haven't given it the right permissions.
All right, I'll wait for you.
I mean, it says that it has them. Let me try one more time.
Let me see if I make you the host completely. Would that make a difference?
Replacing well-manicured slides with live code. Been there, done that. Kailash will tell you. I can't wait to see this.
Well, it all hinges on the ability to actually show you anything that I'm doing, because my guess is that me narrating what I'm doing on my screen without any visual won't be very interesting to anyone. I'm going to try restarting Zoom. I'll be right back.
Cool.
I'm not going to end the meeting for all, though. I'm just going to leave. So I'm going to assign Kailash the host. Okay. Be back in a minute.
Do you all use Clojure professionally or just as like side projects / hobby stuff?
I do use it every day for my work.
Yeah, at Imperity at least, all of our code is Clojure pretty much, both back and front end.
Oh, cool.
Yeah, and I believe a couple of folks are from Imperity in this meeting, like Jeff, Eric, Will, Greg, myself. Majority of us from Imperity at this time. And yeah, Sean Corfield, of course, is works with Clojure.
All right, that looks a lot better. I assume you all can see my screen?
Yep.
Yeah.
Great.
I'm not sure I understand.
Oh, not Siri. All right, let's get started. Apologies for the delay. All right. So yeah, today I'm going to be talking about Pyramid, formerly known as AutoNormal. So I renamed it last week just to confuse everyone that was going to show up today. It was actually like, it took me, I had to increment the version a bunch of times because I kept messing up the deployment to Clojures. So it just makes it look also really mature. I'll be talking about the parts of the library that are quite mature that we're actually using in production, and the parts that are still sort of experimental, because there's an as with all open source libraries, its breadth of its domain is growing slowly. but I hope that by the end you'll have a sense of like some of the problems that it's trying to solve, some of the problems that we're trying to solve at Imperity, especially on our UI, and you know, be excited for what you might be able to do with this library in particular. So first, just a real quick, I think most of you know who I am because you work with me, but for those at home, I am a software engineer at Imperity. My name is Will Acton, and I've been doing Clojure scripts development for the last 4 years, mainly focusing on UI development on mobile and web applications. Also doing a lot of like API and backend service work, but my area of focus for especially the last 2 years has definitely been on UI development. I also have a growing number of open source projects that I maintain and contribute to. Check those out if you're interested in doing UI development, because a lot of them help out with that. And so we're going to be talking about Pyramid today. And so the 1-minute introduction to what Pyramid does is it does 3 main things. Number 1, it is a building block for an in-memory graph database. Question mark there, what is that? I'm going to talk about that real soon here. Number 2 is an EQL engine for Clojure data. More question marks there. What's EQL? What does that mean? I'll get into that later, don't worry. And then the third, which is sort of like the, this is where I talk about its breadth is growing as I continue to think about problems that I encounter. It's also an experimental data log, quote unquote, engine for Clojure data. And I'm going to talk about what that means. So that's it. If you know what all those things mean, and you've already have a ton of experience in other things that might do similar things to Pyramid, you probably already have a pretty good sense of what Pyramid brings to the table. And we'll talk about some of the specifics as well, but like that's the TLDR. I'm going to now dive into each of these 3 ones, and there will be a little bit of a live coding section for each one. Hopefully the demo gods are good to me today. It'll be an adventure for all of us. So first, what's an in-memory database? And I'm using database here because Pyramid differs a little bit, but it's kind of like a fundamental building block for an in-memory database is what I've decided to call it. So they're essentially, they are usually values or these kind of stateful containers that provide additional transaction and query semantics on top of what we consider our normal data structures. So like you can stick a map inside of an atom and just use like assoc and update and get in, and it's basically like an in-memory database. But often we want more power from our we want more power in our applications than sometimes what a plain map provides. And so that's where some of these other in-memory databases come in, like DataScript, Asami, EntityDB, and H2 can provide more like semantics when you're adding data into it and then getting it back out. Very often they handle like stateful connections to them as well. So you can kind of swap them in for like a remote database in sort of an ad hoc way, so that they can be useful for testing things. They can also be useful for just holding state that we're okay with losing after our application shuts down. And so this is interesting to me because most of the time I'm working with applications that store a lot of data in memory and in a browser where we don't really have access to like the file system, for instance. If we are persisting data, then we're making a remote connection to an API, but there's plenty of state that on the client we need to maintain that at the end of the day we just throw away. And so my main interest in in-memory databases came from, we're loading a lot of data about domains over the wire. So we're making requests to APIs, they're coming back. We wanna like keep that data consistent across our entire application. So we wanna accrete those facts over time about our domain. And we want it to be really fast. On the front end, we don't have nearly as much leeway as sometimes we might have in an API layer or somewhere else, in that if something takes a long time, not only it feels bad, right? Like it makes the user experience worse. That's not to say that speed doesn't matter in other contexts, but especially when it comes to these sort of like querying data out of an in-memory database to then show it on the screen. If that hangs the whole web page, that feels really awful. And so my experience here with DataScript, especially, led me to kind of looking for other ways that we could do this, get that same sort of ability to add data to the in-memory database, query it in a powerful way, and have it be consistent across the entire application. So to sort of talk a little bit more about this, to show some of the more specific behaviors that Pyramid has, I have a small demo that I wanted to show. And so in this demo, I have this namespace pulled up, and I'm a big Animorphs fan. Is this, by the way, is this too small for anyone? I see you asking for me to zoom in. Okay, let me zoom in then. Can I do that? Let's see.
And I haven't thought about the Animorphs in like a decade more, maybe.
Can I do?
Is that Emacs?
It is, yes. I
If
haven't
I remember
actually-
correctly, it's Control X, Control Plus.
All right,
Don't
let's
quote me
try
on that.
It's probably big enough when we put it
there we
in
go.
full screen, but in Zoom, there is other things around. Yeah, it's good like this. It's good.
Is that better? Okay, great.
Yeah.
So the example that I have here is I have a few pieces of data about about the Animorphs. And what I'm going to show is that when we first create, so this data, let me explain a little bit more about what this does first. So this data is about like 5, 6 different people. So the initial person, this is about Rachel, who is an Animorph, and she has 5 friends. So that's the initial data that we're starting with. So already we're seeing how often our data is not just like maps about things with no relations to each other. They are often trees or graphs of data that might have like, recursive structures within them. And this, I think, exemplifies it in a fairly simple way, where you have a person that starts with, that has a list of friends, and we might over time learn more information about their friends, and we'd like to keep this view consistent with that. So if we were to store this data alone, and then later want to know like who is Marco's best friend, we would need a way of looking that up that isn't tied to this particular structure. So what Pyramid does is it normalizes your data. So what that means is it's going to look at the data that we add to it. So here I've defined this, and I'm going to create some more space here to kind of get some of this other stuff out of the way. So our initial data is about Rachel and her friends. Now I'm going to create my initial database value. And it's going to tell me that I haven't required this, so I shall require it. and I'm going to define my initial Animorphs DB value. And if we were to look at the new structure of this, move this to the bottom, what we'll see here is the Animorphs pyramid DB value. What it is now is it's a normal Clojure map, but it's been restructured to have all of the entities that it found within the data that we gave it as an initial value is now in this table-like structure. So the way that it is structured now is it starts with the key that it used to identify the entity. So in this case, it's person/ID. That's the.
I will. Sorry to disturb you. Can you just zoom in a bit on that? The
Yes.
font is a little. Thank you.
Great. Thank you for letting me know. So the first level of this nested map is the keyword that it used to identify the entity. So in this case, it's person/ID. The next level, so within that is then a map of the ID values that it found within the data. So here we have information now about person ID 1. And so we know that it's that entity's name is Rachel, and it has these friends, and it's replaced each entity that it found within that vector of friends with a reference instead of keeping the data within there. So now when we go to query this data later, the query engines that Pyramid includes knows how to sort of follow these references around a Pyramid database. But for us, when we add data, it is always going to sort of flatten the way that it stores information about things that it can identify as entities into this table-like structure. What it means is that any information about any particular entity is now a get in away, right? So we can type get in, Animorphs, and if we wanted to know all of the information that we currently have about Cassie, we could do person/ID 2, and that's going to give us any information that we have added to the database about person ID 2, whose name is Cassie right now. I'll pause for questions.
I have two.
Okay.
One is, how does it know that person/ID is an identifier for an entity? And two, how does it distinguish a normal vector with a keyword and a value in it from something that has been flattened into a reference?
Two very good questions. So for the first one, so how does it identify entities? That is absolutely customizable. The default behavior is that it treats any keyword whose name is ID to be something that is identifying an entity. That is purely a default that you can easily override though. When you create a database value, and this might be hard to see. So you can pass in an identify function, which essentially gets called anytime it encounters a map, and then it can look inside of that map. And if that function returns a vector of a keyword and a value, then it will treat it as an entity map, and it will then normalize it into the table structure. And then the second question that you had was about how does it know that something is a reference or just some vector with a keyword and a value after it? It hasn't actually come up much in practice that actually occurs in much Clojure data that I work with day to day. So it will treat any vector of a keyword and a value, just those two elements, as a reference. If it doesn't find that reference, it'll return nil. So that could definitely be confusing. There is like one way to get around that I've discussed in my head, but haven't implemented is I could use like sort of an opaque ref type, right? Or ident type. And one of the benefits that I see to using just a vector is that it's fairly easy to type from a REPL. You can sort of like manipulate it without using too much pyramid specific like logic or data structures. And so I think that if I run into that, or if people like open a lot of requests for like, hey, this is like totally munging all of my data that I'm adding to your that I'm using your library with, then I would definitely, that would be my solution to that, is to switch to like an opaque data type. But in practice, I actually haven't run across too many two element vectors with a keyword and a value in it.
Yeah, a ref or a custom type is probably what I would expect, since it's unambiguous. Another option to play with would be tagging those vectors with metadata, to distinguish them from regular vectors.
Yeah, the reason that I didn't go with metadata is because I guess like my assumption is that metadata would be slower, but that would be certainly worth benchmarking, I think. But yeah, the nice thing is that you don't, so like you can, again, like you can get, if I were to do get in Animorphs person ID 0 friend list, it's going to give me the sequence of vectors, and then I can take any one of those and get in again. So that's, I think, like the power of it, is that using Clojure data to represent these allows you to use like the everyday tools that we're used to like manipulating and retrieving information out of Clojure data. But yes, like in certain cases, it can be ambiguous. So I want to show real quick. Oh yeah.
If you don't mind, what was the motivation behind making IDs customizable instead of mandating that in this in-memory database, this data structure that you're storing it in, that say every first item is the ID of that item?
It's a good question. I think so. When we used it in practice, what we actually found is that there are more cases where you'd actually like to elide, like you don't want to normalize an entity than you do. So like in certain cases, when we were using it at Imperity, we actually found that it was the default sort of like, hey, normalize anything that you find has a name ID in it, was a bit too aggressive. So we actually wanted the ability to say like, hey, only normalize these things that end in ID rather than everything that you find. And so that capability was actually the thing that drove me to adding that customizability in the first place. But the other, there are plenty of other, data is just like sometimes weird. And, I wanted the flexibility to sort of like be able to customize this depending on what kind of project I was, and people definitely were asking for it. I had, one or two people that were asking for the ability to customize this. And so I added it in lieu of a better idea.
Thank you. And then one point of clarification. You told Greg that Pyramid treats any vector with a keyword and a value as a reference.
Yeah.
Is that any keyword and a value, or is that only keywords that by default include ID or otherwise match the customized identity?
I'd actually have to look at the implementation to be sure, but I think it's any keyword and any value.
Okay,
Yeah, really good question.
thank you.
Yes. Definitely, if you find instances where like this would be really useful, if only it had like certain behavior, like it didn't like try and treat this tuple as a reference, or you know, it was more strict, please let me know, because you know, this library is very much like born out of something that I felt was necessary, not something that like I thought was very like I don't know, theoretically interesting, I guess, or something that I had a grand vision for. So yeah, I love these questions. It's definitely making me think about how it behaves.
Well, if you don't mind, I sort of, my initial intuition is both that treating every pair of keyword and value as a reference is likely not to be the right path long term, but I almost like that you're doing it by default and then loosening that later on, because you can't go the other way. If people are using your library and vectors are treated as references, and then later on you say only vectors, you know what, never mind, it's restrictive both ways.
Yeah,
It's restricted both ways. Yeah, you'll have a breaking change whether you go from vector to only IDs, or whether you go from only IDs to vectors.
it'll just give me an opportunity to rename it again.
Yes, that's right. That's why we have numbers.
Great. So that is, I think that people are sort of understanding this. And by the way, this wasn't this table structure. I didn't invent this. This was definitely like I took a lot of inspiration from other similar projects that didn't give me quite the same query semantics. One of them was MapGraph, which is by Stuart Sierra, and another is Fulcro, actually. And I really liked some of the ideas in Fulcro, but I found that I wanted to use it without sort of like the whole package. And so, you know, that drove a lot of the ideas and you know, sort of like implementation of this. Was I wanted to use Fulcro in my application, but I didn't want to download all and add all of Fulcro. All right, so the next part that we haven't talked about that I sort of teased in that first 1 minute intro was EQL. And so what is EQL? I can't go into all of the specific semantics and capabilities of EQL, but I'll give sort of like a short summary, and then I'll try and show some of the things that it can do. So EQL it stands for Eden Query Language, and it is, as the website notes, a declarative way to make hierarchical and possibly nested selections of information about data. Another way of thinking about it is if you're just thinking about a Clojure data structure, it's sort of like select keys on steroids. And that's actually the way that Pyramid works, is that you can certainly use these, you can use its pull function on a Pyramid DB value, and it will like, you know, follow any references that it finds, and I'll show that. But you can also use these EQL queries with the Pyramid pull function on any map, and it basically acts as a select keys on steroids. The thing that I like about it is that it can easily describe large trees, including recursive trees, in a succinct format, and it is just data. So unlike things like GraphQL or other sort of like query languages that are taking a graph and sort of trying to get it as an output, a tree of data. It's just Clojure data. And so we can like write it super easily within our IDEs without any additional plugins. We can, bash on it, to build the queries up programmatically. It's quite nice to use in a Clojure project. And then if we have time, I'll also talk about how its usage with other libraries like Pathom and which is sort of like a GraphQL service-side and client-side API, and Walkable, which is like a way of creating SQL queries out of this. Combining those service-side libraries with a client-side in-memory database is actually like a superpower, and you can create a really interesting like sort of client-side cache for a service-side or API framework out of it. For this demo, I could show you from the REPL, but there's also, I found, I found that as I was working with a lot of these big DB values, especially at work, that it was much nicer to be able to sort of like have a little like UI for constructing them and also like exploring these databases. And so what I did, if I can, I hope that's not like insanely small. I'm going to rely on y'all to yell at me if it is. But this is a small little web application that I created that already has the data that we were working with loaded inside of it. And what we can do is we can write our EQL queries directly in it, and then it'll show the results on the right-hand side. So one of the example queries, I'll just scroll down here and paste it, is if we look at what our pyramid database looks like, we can see that this is after we've accreted some more information about our anamorphs. So we have here that Marco has a best friend, and we might want to write a query that says like, hey, for that person ID 1, who we at this point know as Marco, who's their friend or who's their best friend? And so the query that we would write for that is we could start at person ID 1, and on the right hand side here, we'll see that that just returns the whole like the whole entity, but it doesn't follow any references. So we can see that that bottoms out at a person ID 3 map. And what we're really interested in is we want to know their name, right? So we can follow this by wrapping it in another map, or we can wrap it in a map, and then we can say, okay, I want to know the person that we're talking about's name. So sorry about this. I knew I was angering the demo gods by doing this. Here we go. So we're going to get the person's name that we're talking about, Marco, and then we're going to get their friend. So friend/best here. And that's going to return the entire entity that is contained within that friend/best keyword. But we only really want their name. So we can like select further if we want to. We could say, wrap this in a map again, saying that we're going to select more keys. This is called a join in EQL. And then we're going to say person/name to say that we just want the name key. And so the way that I read this EQL query which if you're not familiar with it, can take a minute to like start to get up to speed on it. It's fine if this looks a bit like gibberish right now. But what we're trying to do is we're trying to describe the data that we're going to get back. So what we're saying is starting at the entity that is identified by person ID /1, then select the name, and then also select the friend /best, the value there. And then within that, go even deeper and just select that person's name. And so then what we get back as the result is a map containing the key, which is the original like ident that we passed in there, the reference that we passed in saying start here, and then that person's name, keyword saying that like, okay, this is their best friend, and then their best friend's name, which is Jake. And so actually, before I say any more, I'll pause.
And I think in chat, Alan is asking a question like, is this like GraphQL but for Clojure forms?
For some reason, I can't find my chat. Well, there it is. Yes, so it's very similar to GraphQL in terms of like the query language. What the difference is that there's no schema language for this, right? So it's purely a language of like write a query, get a result back, and then you know, you can pass it to whatever engine is going to sort of like parse that query and return the result. So pyramid, you pass it a query, it's going to look at the DB that you pass in or the map that you pass in and try and walk the data structure. With Pathome, Pathome has similar to like if you've ever built a GraphQL service, it has a way of registering resolvers to try and meet the data needs of like whatever keywords you have. And so it's much more dynamic in that way. Do I support some params for the requested attributes? So pyramid is all about pyramid is in a way very dumb. Whatever data you add to it, you can then query for and get back out. So what he's asking about is there's a way of writing parameters in EQL. So like one, for instance, might be like, maybe I was describing like an HTTP request, for instance. So I could say HTTP rec, and then, you know, I'm going to say the URI is API /v1/ you know, I don't know, people. And then the method is post. And this is a perfectly valid key in a map. And so what it would do is instead of treating this, this essentially a tuple as some parameter to like use in some special way, what it would do is it would look up this tuple as a key in the map and try and follow it. So it doesn't treat parameters that are given to these attributes specially in any way. It simply treats, you know, you have either a key that it tries to look up in the map that you pass it, or it's trying to join on like whatever data structure is returned by that. I know that might have been a little bit confusing, but does that adequately answer your question, Vincent?
Yeah.
Okay.
I have some questions.
Okay, I'm willing to answer.
I'm taking a look at the source code at the same time. I see a method called delete nested entity, but just now I realized it's a private method.
In the pyramid code?
Yes.
Yeah,
It's
so
called by delete. I wanted to know if you want to delete some nested data inside your local database, or do you do using Pyramid?
yes, so it does have simple support or for deleting data. So you can, for instance, like evict one specific entity and any references to it. One thing that I want to I'm planning on working on soon is going the other direction, saying that like, okay, here's like a key in a map. Now walk that, walk down that, follow any references and delete all of the data that like shows up in walking that. And specifically, I want to add the ability to detect like, delete this, any entities found in this, as long as it's not referenced by anything else. So that's going to be something that like I want to try and do, but because I think that it would be very useful for basically using it as like a cache eviction like method, where if I'm storing like results from an API, and then after a while, maybe the user has navigated away to another screen, I want to evict that data that was requested from the API because it's stale. It's a little bit harder to do that with this sort of like normalized database, normalized table format. So that's something that like I want to try, but I'm not sure if I'm going to be able to do yet.
You want to implement a kind of garbage collector then?
A kind of what?
Garbage collector.
Yes, exactly.
In a garbage collector, you don't know in advance what was placed inside the database, and you have to discover that. Maybe if you keep track of the things that has been inserted in the database, and if you give the users the tools to remove those things which have been added into the database, then you don't need to discover what is not referenced anymore.
Yeah, I for now, it's definitely something that you could implement sort of like outside of Pyramid. And so I think that there could be, I definitely don't want to be in the business of counting people's references. So I have a separate project that I'm actually working on for sort of like using Pyramid as a client-side cache for a Pathome API. And so I'm sort of going down the path of like exercising, like, what do I need to do in order to, do I need to count the references? Okay, I probably don't want to do that inside of Pyramid then. I'd rather do that outside of the DB and then like selectively sort of like evict things as I the sort of like higher level like application or sort of framework layer understand that they're not needed anymore. So you're probably right in that regard. All right, I'm going pretty long, so I'm not going to have time to talk about everything that I wanted to. There was at the end this super secret side project that I wanted to show that builds on top of Pyramid. I'm not going to have time to show that. I think that'll be okay. The last thing that I want to show today is something that I added relatively recently to Pyramid, which is the ability to use like Datomic or DataScript query syntax for querying a map or pyramid DB. This was definitely inspired by like other people in the community. So there is another project called Doxa that implemented something pretty similar to what Pyramid does. They have a slightly different like sort of like normalization table structure. And so I couldn't just like use their data log query engine to query a Pyramid DB. And so, but I was like, oh, that seems like pretty neat. And it's actually, you know, the way that it has manifested itself in my usage of Pyramid is it's incredibly useful when trying to debug or explore a really large, you know, nested map that I can sort of like quickly pull out information using a data log query and then use that to help me troubleshoot like, okay, why is this component rendering something that I didn't expect? It's different than the EQL queries that I showed before because the result of a data log query is going to be like a list of like facts. So it's going to be like a list of scalars or like strings or numbers or something like that, or a list of tuples that like describe the variables that you add at the top, which I'll show in a minute. It's not going to be this nested tree of data like you can get from an EQL query. So lots to be still done here. The biggest thing that I really want right now is I want the ability to embed an EQL query inside of the result of a data log query. That's the next thing that I will do as soon as I have like, I don't know, a week of free time. Who knows when that will be. But in the meantime, like I said, I'm finding it very useful for sort of like just doing this sort of ad hoc exploration of a map. So let's go back to this little app that I built, and we can you can select which like query syntax you'd like to use. So the default is pull, but in this case, we're going to use data log. And then I have a couple of queries here that I saved to hopefully save me from the demo gods. So this first query, I copy it and paste it here. What this is doing is it's saying, let's see if I can get it to format. Not really. Here we go. So what this query is saying, if you're not familiar with like DataScript or Datomic query syntax, is it's saying find all of the tuples of a name and their friend where, and then this is where it gets a little hard to describe. So it's a binding a value here. The entity needs to have a list of friends, and the entity also needs to have a name. And so we bind the results. So if it finds an entity map that has both a friend list and a person's name, then it will bind these right-hand values. So it'll bind the friend list value, so that'll be a vector of references to this friends variable. And then it'll bind the name to this question mark name variable, which we have in our result. So that's sort of the first part. We could even start just with that. We could say that like this, what this will do is it'll return, I'll delete this. I'll talk about that in just a second, Vincent. That's a really good question. So what this is doing is it's returning, I'll say friends. So what this query shows is it's returning all of the entities in our pyramid DB that have a friend list and a friend name, which is all of them. And then it returns specifically the name value that it finds within that entity. So we see each of the names: Rachel, Marco, Cassie, Jake, Tobias, and Axe. Now, what we might want to say, and this is the original query that I had written here, is like, okay, for every person who has a name and has a list of friends, tell me like what the names of all of their friends are, and return that as a result. So what we can do next is say, okay, for each of their friends, give me the person's name and bind that to the variable friend. Or let's say friend name, just to be explicit. And so then we can add this friend's name to the results. And what we would expect to see here is a bunch of vectors where the first element is the person's name and the second element is their friend's name. And we would see a bunch of repetition on the left-hand side, and on the right-hand side, we would see each unique friend name. But we don't. And your question, you asked, what is the use of the many metadata that was on my original query? Pyramid has no schema, so it doesn't understand when it encounters a collection of references or a collection of values, whether to treat that as the value that it should use in the result or in the binding of that to use in the next clause in this case, or whether it should treat each value in that collection as its own value that it should then like iterate through. If you've used a database like Datomic or Datascript, it has a schema that describes like, this is, a collection of entities. This attribute contains a collection of entities. And so that's how its query engine knows that, okay, when I'm binding a value to this, I'm going to bind each value to it, and I'm going to run the next clause for each of them. So when we're writing a query against a pyramid database, what we need to do is we need to tell it that this friend list value is actually going to contain many different values, and to treat it as like each value within that collection as its own like value that it should use in one of the clauses in the future. And so by doing that, we see that our query actually succeeds. So we see what we expect. We get, for the person who's named Rachel, one of their friends is Marco, and then another one is Cassie, and then there's Jake and Tobias and Axe, etc. Does that make sense, Vincent?
Yes, I still have another question.
Okay.
I finished to write it down. So could you infer that, the symbol question mark friends is an entity from the rest of the data log query, and based on that, look for some references to entities inside collections without having to manually write the metadata many?
I think that we could if all we cared about was collections of entities, but there might be cases where like the right-hand side, the value that we're binding, we might want to use that in some way that isn't an entity reference, but still treat it as like a collection where we like use each value inside of that collection as another value in another clause. And so that's why I added the ability to annotate a variable with the many keyword so that you could write more dynamic queries. Another example could be, trying to think of a good example. There's not really a good example here with the data as we have it, but you could think of like, let's say that instead of tuple, or let's say instead of the friend list, if it wasn't actually a reference at all, we didn't have that information yet, we just had the friend's name, we could then use that in the clause in another clause to say like, okay, now find the entity whose name was, whatever that value is. If we assumed that we could only like use collections of entities that as like, if we only traversed inside of collections that were only entities, we would lose the power of that. I hope that makes sense.
I see. Yeah, I see. It makes sense. I forgot that the entities could be on the right side of a relation as well.
Yeah. Really good question, though. That is definitely like the most the biggest difference is Pyramid has no schema and doesn't really take that into account. Like one of the ways there's another in-memory database called Asami that is very, very similar. It has a very similar API to DataScript, but it has no schema. And the way that it gets around this problem is every attribute is a collection. So every attribute, when it's stored inside of the Asami database, is its value is a set. And so you can like add more values to it. And when you're adding stuff, you have to tell it, hey, this is like, replace whatever is there versus like add, just accrete to that like set that's in there. But when you're querying things, it makes it much simpler because you don't need a schema to tell it whether this thing is a collection or just a single thing, because all attribute values are collections at that point.
Something that might be convenient from a consumer perspective is if you could provide a schema at query time. So not like, I guess, DataScript where you kind of have a schema baked into the like DB connection atom. But if you could provide that as an input to the query, it might be more convenient from the caller's perspective to be able to define these keys are collections or other qualities of the schema that that are going to be true about your data for every query, and be able to like define that once and pass it in instead of having to remember to like tag every relevant clause with the many keyword. Because I could see you forget that on one of your queries and you're like confused why this works in one place and not the other, when that property of collectionness is going to be a like fact about your data everywhere.
Yeah, that's a good idea. I'll definitely think about that.
My question was the same.
Yeah, it sounds like what you posted in the chat is like the exact thing that Greg was saying. Yeah, that's interesting. I'll think about that.
Looks cool though. I love me some data log.
Yeah, it is. Yeah, me too. And when I posted about this the other day in the Clojure Slack, I think someone maybe they said that they went and benchmarked it against DataScript, and they said that it was, I think their words were, a good first pass. And so it's not, I don't intend to use this data log query engine like in production as something that we would like use within like some piece of UI that needs to be like super performant. The way that I'm using it right now is mainly like I have this really large DB value, pyramid DB, or a really large map that I want to maybe just like explore a little bit, and see like make some assertions about it that maybe like allow me to learn more about the data that's contained in there. And so data log is a really powerful tool to use in that. But most of my performance work has been on the EQL query engine, and that's where I intend to like spend the most of my time, because I think that in practice has been like the most useful And if I need to like get some, sort of like specific individual facts about an entity, it's always going to be faster to use like the basic map functions like get in or filter or, et cetera. And so, I was sort of, my experience with data script is sort of like informing this, where a lot of the time I would write a data log query, I'd find it to be slow, and then I would revert back to like, okay, just give me the entity and I'll like, start to like use that as just like Clojure data and like, filter and, get keys out of it, et cetera. And that was like, that felt a bit bad. I was a bit disappointed in that. But I don't think that I'll be able to make my data log engine much faster than data scripts. So in lieu of that, I'm just not going to try right now.
I really like your playground. Do you publish a source code for that?
Yeah, the URL is pyramid.lilac.town. So yeah, I use it. Like I said, like a lot of times, like even in production, you can like dump the DB value and then like pick it out and place it in here and then start to write queries against it, which is pretty useful. And I find it a lot easier to use than my Emacs buffer sometimes, because it kind of chokes on some of the larger map values.
But I don't know where to find the source code.
Oh, the source code? The source code is in the Pyramid repo, actually. So if you go to site, the source is all in here. Yep. Thanks. Yeah, for sure. Hey, I really appreciate everyone's time. I think that's where I'm going to end it. Yeah, if any of this sounds like super interesting to you, reach out. I'd love to chat more. Definitely, like, feedback is appreciated. Yeah, I hope to be able to share something even newer and cooler the next time that I'm here at Seajure.
Cool.
Thanks a lot.
Lo.
Thanks.
Thanks, Lovell. And I'm going to stop the recording and open it up for some more questions, if any.